Hello, geometry students. Welcome back to another geometry video today where we are looking at part 2, the second set of notes for isosceles triangles and their relationships that they have between angles and sides. So again, yesterday's video talked about sides and angles, identifying which ones are the smallest and the largest. Today we're going to look at how we can apply theorems about isosceles triangles to find angle measures and side or segment lengths. So again, yesterday we talked about this piece. The largest angle will be opposite the longest side. The smallest angle will be opposite the smallest side. Okay, and that was from some of the different properties we have with all triangles. Okay, and we practiced with a little bit of that. Well, here's the important note number 2 as it deals with an isosceles triangle. So let's look at this picture on the left-hand side first, okay? An isosceles triangle has to have two sides that are of equal length, two sides. We mark them with these little congruency marks, tick marks, I might call them, to show that the left side here is congruent to the right-hand side. However, from chapter 6, and what you really want to make sure you have, and this may have been actually from chapter, 3 maybe, but this picture gives us a more definitive way of looking at an isosceles triangle, okay? We've got the two congruent sides, left side and right side, and where do they meet? Like if I follow them up to see where they meet, we call that the vertex of the triangle, the vertex. If that's the vertex of the triangle, the angle right underneath it is the vertex angle. That's important to know that that's the vertex angle. Then if we follow back down to the other side of the triangle, we have two other angles that we're going to call the base angles because the side opposite the vertex is called the base. So if the vertex was up here, because the two sides met up top, the base is opposite that, meaning the two base angles are down here. I would make sure you have that picture drawn somewhere. Now that leads to this really, really important property and a name that we give to connecting the vertex to the base. This distance from the vertex straight down to the base, right? Let's just take, let's take green, and I try to connect it straight down, it's going to intersect at a right angle, and it's going to create what we call an altitude, or the height, how tall the triangle is. The altitude or the height. All right, and what it actually does is it cuts the base into two equal parts. All right, it creates two equal parts down here as well. But this is all different properties that exist in only an isosceles or an equilateral triangle. Okay, so make sure that you have these vocab words down up here from this picture, and also that we call this the altitude from the vertex to the base. Now, what does that do, right? How can we use all of this information to help us identify the parts of an isosceles triangle? What's the base? What's the vertex? Draw the altitude. What are the base angles and what are the vertex angles, right? And we've got A, N, and G. Now, we've only got two angles labeled, 71 and 54. Therefore, what is left for the angle down here in the bottom? What's left? Well, that's going to make 71, and 54 is 125. 125 subtracted from, let's say, 180 is going to be 55 degrees. So we don't even have an isosceles triangle. This is kind of strange. We don't have an isosceles triangle. So we're going to change something up really, really, really quick. We're going to make this one 70. And if I take one away from here, I'm going to make this one 55. Right? Now I have an isosceles triangle because two angles are also congruent. Okay, if the two angles are congruent, those are base angles, means the opposite sides are congruent. So the base, right, here's the two sides that are congruent. Left side and the right side are congruent. That means the vertex is at angle A. Right? The vertex is at angle A. The base is opposite that. Well, what do we name this segment over here? Segment NG. Draw in the altitude. I kind of did that, but we'll do it again in red. The altitude is going to drop straight from the vertex right down there and create a right angle. What are the base angles, right? The base is this right-hand side, so the base angles are angle N and angle G. Those are the two base angles because the vertex angle is angle A. And I should have erased the angle up on top of the vertex. The vertex is just a point, right? And so if we can identify where those two congruent sides are, and we know this because the angles are congruent, the sides will be congruent. And that leads us to this last property right here, right? Isosceles triangles will have a symmetry line which passes through the vertex and the midpoint of the base. They're going to pass through that. All right, meaning that it's going to have a midpoint and cut them into two equal parts right there. It also will cut this angle into two equal angles. And so we can do a lot of investigating here. Notice, right, this side is 5.38, and this left side, GN, is 5.38. That's what makes it isosceles, but we can also tell that because the angles opposite those two congruent sides, those two angles are also congruent, 68 and 68. So every isosceles triangle, let me just try and draw you this picture. If this is an isosceles triangle, and I know this side and let's say this side are congruent, I know that the two angles opposite right here is congruent to the angle opposite right there, that those two are congruent, that this is my vertex, and this then opposite is my base. And that's what we can kind of identify based on these isosceles triangles. Okay. Now remember, right, it's going to drop at a 90-degree angle. So I could look at this as two triangles as well. A triangle here on the left with 68 and 90. Well, that means I need, what, 22. Let's draw it outside. That angle up there on the top is going to be 22. This side is also 90 and 68, which means this angle would be 22. And that's why the altitude of this particular triangle, isosceles triangle, can also become very important. That's what you're going to be looking at a lot today. Make sure you've written down some of these examples. When you get to the practice problems out of the textbook, give them your best shot. Check your answers when you are done. If you have questions, make sure that you reach out. Otherwise, until next time, everyone, stay safe.